All right, so we're going to discuss the first basic differentiation rule, which is the derivative of a constant. So remember that the derivative is equal to the instantaneous rate of change. And we talked about in class how this derivative is defined as f prime of x, and it's equal to the limit as h goes to 0 of f of x plus h minus f of x over h. And we went through some examples in class, very tedious, where we evaluated the limit using all of our limit rules, and basically sometimes these questions are like a page long trying to evaluate this limit. So what we're trying to do in this next section is actually come up with some rules for differentiation so we don't have to go through this very tedious process, long process every single time to find the derivative. So the first type of function we're going to look at is the derivative of a constant. So we have this notation d over dx, and this is our derivative notation, and I kind of think about this as meaning that we want to take the derivative of whatever follows. So I'm going to always abbreviate derivative with dx, but we're going to take the derivative of what follows, and in this case what follows is 5. So if you think about drawing the graph of 5, you would have y is equal to 5, and hopefully you remember that that's a horizontal line. Now, if you look at the rate of change from here to here, from here, from here, from here, the y values are never changing. So when we think about our derivative as the instantaneous rate of change, that means that the derivative of 5, there's no change here, it's always 5, and so that is going to be equal to 0. So this quick example gives us our first derivative rule, and that is if we have the derivative, so d over dx is the derivative of a standalone, all by its lonesome constant, that will go to 0. So it will be equal to 0. So just two quick examples. If you have, for example, the derivative of pi, that is a standalone constant because that's just our 3.14, so that will be equal to 0. If you have the derivative, for example, of -2, again, that is a standalone constant, so we say it's equal to 0 because our instantaneous rate of change is 0. So the derivative of a standalone constant is equal to 0, and that is our very first, number 1, derivative rule that we're learning. So derivative of a standalone constant equals 0.